So today we're going to do another day of angles. We are going to focus on vertical, complementary, and supplementary relationships. We are also going to talk about adjacent angles in which it gives you a sum, and the sum doesn't necessarily have to be 180 or 90. It could tell you what the two angles equal. As always, please remember to do your do now, watch the video, complete the Google form, and then complete the reflection. The vocabulary words to remember: vertical angles are equal and they are across from each other. Supplementary, the straight line, they sum to 180 degrees. Complementary, they sum to 90 degrees. And adjacent, they just add up to a certain sum. They share a common ray, but the sum does not have to be 180 or 90. So let's look at the first one. These are adjacent angles. We have angle ABD, which is the large angle, and that measures 164 degrees. We need to find the measures of angle ABC, which I'm going ABC, I drew in blue, and then we need to also find the measure of angle CBD, okay? So we know together they equal 164. So 2x plus 23 plus x has to equal 164. We combine our like terms and we get 3x plus 23 equals 164. We subtract 23, and we get 3x equals 141. We divide 141 by 3. And we get x to equal 47. Now, x is 47. That is not the measure of those angles, and some people made that mistake yesterday. You must sub back in 47 for x. So this would be 2 times 47 plus 23. And we would get angle ABC equals 117. Okay, the same thing. And now you know angle CBD was just x, so we know CBD was 47. Okay, so after you get x, if it wants the measure of the angle, you have to look at what angle and sub it back in. So let's look at another example. Angles DEF and WXY are complementary. The measure of angle DEF is 2x, and the measure of angle WXY is 3x minus 20. So if we know they're complementary, their sum must be 90 degrees by definition. We combine our like terms, so we get 5x minus 20 equals 90. We add 20, we get 5x equals 110. We divide by 5, and x is 22. So that is the value of x. However, we also need the measure of WXY. So we know it was 3x minus 20. We have to sub in 22 for x, and we get 66 minus 20 equals 46. So the measure of angle WXY equals 46. The next example, adjacent angles. If two angles are adjacent, that doesn't necessarily tell me that they are equal to some degree measure. But if you look at this diagram, these two angles total 78 degrees. So it doesn't have to be like 90 or 180. It could be a different measure. In this case, it tells me the whole angle is 78. So I know 30 plus m is 78. I subtract my 30, so m in this case is 48 degrees. So we're going to look at another one like that. These are adjacent angles. Together, they are 72 and 3/10. So we know that's 26 and 4/10 plus u. So I subtract 26 and 4/10. And I get u to equal 45 and 9/10. Okay? That is just setting the two angles equal to the total. So now we have angles and their supplements, or angles and their complements. In this case, they're supplementary angles. The measure of the first angle is 142 and 5/10. We need to find the measure of the supplement. So because they're supplementary, by definition, they're equal to 180 degrees. So I just set up my equation and I solve. 180 minus 142 and 5/10 gives me the supplementary angle to be 37 and 5/10 degrees. Okay, so we'll look at that now with complementary angles. So the measure of an angle is 55 degrees. We want to know its complement. So because they're complementary, by definition, they're equal to 90 degrees. I subtract 55 from both sides, and I get it to be 35 degrees. So with some of these examples, you're going to have to think of what equation to write. So let's read this one. The measure of an angle is 17 times the measure of a complementary angle. What is the measure of each angle? So we have two angles. We let the first angle be x because we don't know it, right? And then we know the second angle is 17 times it. So if it's 17 times it, we can let it be 17x. Okay? Together, they would be 18x, and because they're complementary, by definition, they're equal to 90. So we do 90 divided by 18, and we would get x to equal 5. So the first angle is 5 degrees, because I sub in 5 for my x, right? And the second angle is 17 times 5, or the second angle is 85 degrees. Okay, let the first angle be x and write the relationship for the second. So let's look at this again. An angle measures 60 less than the measure of the complementary angle. What is the measure of each angle? So if we have the first is x, an angle measures 60 less than the complementary, so the second one is going to be x minus 60 because it's 60 less than. So together we know it's 2x minus 60 by definition is equal to 90 because they're complementary. I solve this like a two-step equation and I get 2x equals 150. I divide by 2 and I get x equals 75. Now I need to know the measure of each angle. So in this case, the first one is going to be 75 because it's just x. The second one is 75 minus 60, and the second angle is 15 degrees. So the angles are 75 and 15. Let's see how this applies with supplementary angles, okay? So the measure of an angle is 5 times the measure of its supplementary angle. So we let the first one be x. The second one, if it's 5 times it, it would be 5x. So we know it's 6x because they're supplementary, their sum is 180 degrees. So I divide by 6 to both sides and I get x to equal 30. We want to know the measure of each angle, so then I sub it back in. The first angle is 30 degrees. The second angle is 5 times 30 degrees, or 150 degrees. Okay. The next example is the vertical angle relationship. So if you look, you see the angle that I outlined in red is 66 degrees. We know that is a vertical angle to the angle that I outlined in blue. But the blue angle is C plus 40. We know they have to be equal. So now we can solve for C by subtracting 40 from both sides, and we get 26 equals C. Knowing that vertical angles are equal, we can set this relationship. I am going to show you one more like that. So I notice a pair of vertical angles. I notice the blue angle, which is 64 and 7/10. I notice that is vertical to these two adjacent angles, which are V and 27 and 3/10. So I know V plus 27 and 3/10 has to equal my 64 and 7/10. So I subtract 27 and 3/10. And I get 37 4/10 equals B. Okay, so that's using vertical relationships to find the unknown part of an adjacent angle. The last example I want to show you is solving for the variable and then subbing it back in one last time. So we have angles Y and Z are supplementary. So because they're supplementary, we know their sum must equal 180 degrees. Their sum, so I have x minus 8 plus 4x minus 12 has to equal 180 degrees. So I combine my like terms and I get 5x minus 20 equals 180 degrees. I am going to add 20 to both sides and I get 5x equals 200. I divide by 5 to both sides and I get x to equal 40. That's not my answer because I wanted the measure of angle Z. So I take the 40 for x and I'm going to sub it back in to the expression for Z. So it's 4 times 40 minus 12. And I get 160 minus 12, which equals 148. So the measure of angle Z would be 148 degrees. Okay, hopefully that clarifies some of the reflection questions from yesterday. So as always, please try your best. If you need help, it is best you join my Zoom at 10 a.m. or 11:30 a.m. I will help you live. Remember the 3 main relationships that help you find angle measures are supplementary, sum to 180 degrees, complementary, sum to 90, and vertical are equal. Okay? Try your best on today's form. Any questions, you can ask me live or email me. IXL will be coming soon on Monday. So have a great weekend and feel free to ask any questions that you need help with. Also on your reflection, just like yesterday, please ask specific questions so I can answer them on Monday's screencast. Have a great weekend.